So here are our basic rules for integration for finding the antiderivative. We have the integral of k dx. Remember that k is a constant. So just like the other rules for differentiation, we used k for our constant, we're going to do that here. We've got our basic rules. The integral of k dx is going to equal kx plus some constant c. The integral for k times f of x dx, we're going to take that constant to the outside, find the antiderivative of f of x, and then from there, we'll be able to multiply that antiderivative that we find of f of x times k. Another rule that we'll want to have memorized is rule number 3. If I have more than one term, or if I have a combination of two functions that I'm adding together, I can find the antiderivative of each one of those functions separately and add those antiderivatives together. So the antiderivative, or the integral, of f of x plus g of x dx is equal to the integral, or the antiderivative, of f of x dx plus the integral of g of x dx. And I'm going to start saying integral, and I don't want that to confuse you, but it's important that you understand that this is an integral sign. Okay, so this is an integral sign. So some of these things I'm going to try and say several times so that you keep hearing it. Here, number 4, same as number 3, except this time we're subtracting. No different. The integral of f of x dx minus the integral of g of x dx. Now the integral without the differential means nothing. So it's very important that you have that differential. So when I say differential, I'm going to mark the differential in gold. That differential is crucial. And we will be talking about how this all develops and where that comes from, but we're going to start off slow in this video. We're going to get comfortable with our terminology, and then I'm going to go back and I'm going to explain some things. Here we have the integral of x to the nth power times dx. That is equal to x to the n plus 1 power over n plus 1 plus c. N cannot equal -1. Now, as much as you think that you can get through this lesson, maybe even a few of the sections beginning in this chapter without memorizing these basic rules, the value of knowing these rules will come through as we get deeper into this chapter. So please, please, please make sure that you're making your flashcards and you're seeing what these rules, how to apply these rules, what they look like. For instance, number 1, when you put the integral of k dx, I'm going to highlight that. When you put this on one side of your flashcard and you put kx plus c on the opposite side of your flashcard, it will help you tremendously to get through the practice, to get to the next level, to build on what we're doing. It will just help you make sense of it all because you won't be struggling over the basic facts. Okay, let's practice a few. Here we want to find each indefinite integral. So now I'm going to start using the words indefinite integral. Indefinite integral means the basic, the general function that is the antiderivative of, for instance, 1/2. So we have the indefinite integral 1/2 dx. Well, what rule is this? 1/2 is my integrand. Dx is my differential. So this is a constant times dx. And that is rule number one. Rule number one. Rule number one says the integral of k dx, the indefinite integral, and we will talk about definite integrals. Again, we're going to get used to the terminology, the vocabulary, and then you're going to be able to understand the difference between an indefinite integral and a definite integral when we get there. But right now we're going to get comfortable saying the indefinite integral of k dx is equal to kx plus c. So this is going to equal 1/2 x plus c. Is the c important? It's not only important, it's crucial. Crucial with an indefinite integral that you have that constant at the end. Here's another example, the integral of 1 dx. Now, we could even write this as the integral, the indefinite integral of just dx. That's the same thing. It's got a coefficient of 1. This is also rule number 1. And that's going to equal 1x plus c, which we write as just x plus c. And then we have the indefinite integral of -5 dt. -5 dt. Go ahead and see if you can give this one a try, and then check your answer with mine. So my answer is -5t plus c. -5t plus c. So the differential of dt dictated that our variable is t, not x. And then of course we always add that constant when we're working with indefinite integrals. Okay, example 3, example 4, we're going to come back in the next video and we're going to work with those. So rule number 1, hopefully we've got under our belt. Now we're going to go to rule number 5. So we're going to work with rule number 5 and maybe even rule number 2. So rule number 2, rule number 5 is what's coming up in the next video.